Right, so I'm going to talk about the actor model. So what is an actor? Actor is a unit of execution. It's defined by three basic properties. So it can receive messages, it can send messages to other actors, and it can create other actors. So here I have a couple of examples. This is probably not in any specific programming language. First one, I define a class actor, function receive message. It prints out the message contents. Then it alters its state based on the message. So actors can also have an internal state which they can alter. In the below example, I'm actually creating a new actor based on the message. And it will become a child actor of this actor, so actor systems are usually hierarchical. So how it does it? So actors handle one message at a time. So there might be multiple senders from different sources to the receiving actor. And if there are more messages that it can handle, those will be buffered into a mailbox in front of the actor. And also in actor systems, the message order is mostly indeterminate. So callee actors don't really care necessarily in which order the messages flow in. And here I have another example of where in the receive function, I will actually forward the message to another actor. This actor knows. So they don't use this receive message interface. There's this generic interface between actors. So actors don't know the implementation details of how the other actors handle the messages. So why use actors? Well, first of all, due to this property that they will receive messages one at a time. Actors are very good at protecting their internal state. So no need for locks or synchronization or any of these traditional multi-threading concerns. Also, this means that actor systems protect their whole state quite well. Concurrency, since actors are so atomic, they don't share memory, they don't share anything with each other. They share state only by message passing. They can run concurrently, so two or more actors can execute code at the same time in whichever order, doesn't matter. So some implementations, probably currently the most famous one, Erlang. Then Elixir, which we'll take a look at in a bit. Then some libraries framework for other programming languages, Akka, for JVM languages, C#, Proto framework for Go, and so on. So Erlang, developed by Ericsson in the late 80s, would have probably remained pretty much as a lab project if it would have not been this telephony exchange project Ericsson started in the mid-90s. It was the biggest industrial project in Sweden at the time, estimated 10 billion Swedish crowns. It turned out also to be the biggest industrial disaster in Sweden in the mid-90s. The project failed. Root cause was deemed to be C++. It was a new language for Ericsson, and its object-oriented nature was something unfamiliar to the developers. Erlang came to the rescue, and the next project was done successfully with Erlang. Then Ericsson later in the 90s open sourced it. Elixir, first version released in 2011, created by Ruby core developer Jose Valim. He was trying to first solve concurrency issues in Ruby, and he ran into this Erlang and especially liked its runtime abstractions, and created a new programming language which runs on Erlang runtime. So Erlang runtime, it has this abstraction code process. It's very similar to the operating system process. So Erlang processes have their own memory, their own stack, But now when I'm talking about processes, I'm talking about this Erlang process, not operating system processes. And processes communicate with each other by message passing, so they are in effect actors. This is an example how an Erlang runtime could be set up in a single machine, 2 core machine, 2 native threads machine. So there's this Erlang scheduler running in a native thread, which then runs the processes in a process queue. So let's take a look at the process example, a concrete example. This is now Elixir. So I have defined a module, my process, the syntax. Some of you might know Ruby. It's very Ruby-like. As mentioned already, it's a fully functional language. It has weak dynamic typing, so there are types, but they are resolved runtime. And here we have in line 3, we define a function. Then in line 4, keyword receive, which means that we are now receiving one message. Then lines 5 and 6, pattern matching in action. We are receiving this add message. So what this process is doing is adding A plus B. So we have a tuple. First add is an atom, similar to enums in other languages. So when we receive that kind of a message, we will output it to the IO standard output. Same thing for subtract. Then as this is receiving, it is sort of blocking until it has received message, we need to recursively call again this listen messages, so we'll get to the receive block again. So let's run our process then. So in bracket 2, we can see the spawn. So this is a create actor. So we spawn a new process, and we get the process ID back. Again, this is not an operating system process, it's an abstraction inside the Erlang runtime. And what you're seeing here is actually Elixir shell, so Elixir REAPL. And here we can run code. So we have spawned a new process. Next we send to that reference. So we don't know the concrete implementation of our process, we just use the generic interface. Send it a message, add 1 plus 2. Then that other process my process will now output the result 3, and that send actually outputs that line add 1, 2. So send function call returns the message it has sent. So those 2 outputs come from different processes. And the same thing for subtract in bracket 4. Let's make the process a bit more complicated. We have now added a sender, so lines 5 and 6. So the message is now, this is expecting, has the sender added to it. So instead of outputting the result here, we send it back to the sender. So we have added a new message result A plus B, which is sent back to the sender. Again, spawn process, get the process ID, the address of this actor, in actor terminology. Then we send it again a message. This time we have added this self function call, which will get this process's process ID. Everything is a process in Erlang or Elixir in the runtime. So now you can see that it indeed prints only the result of the send function call, so only the message that has been sent. Erlang process info now, with that we can check our mailbox, and there we can indeed see the result message, and inline call bracket 5 we can then output to the IO standard output the result contents. Here, when you code with Elixir, you probably don't want to use such a low abstraction level. There's plenty of better or higher level abstractions in the standard library. So here is this gen server. It sort of abstracts this client-server relationship. We don't have time to go into too much detail of this now. This is sort of the same example as before. Instead, here we have now added this internal state. So within it, we initialize state with 0. Then with this add and subtract messages, which are under the handle cast functions, we asynchronously, so without reply to the caller, we modify our internal state and handle call will then synchronously reply to the sender. So where you could use Erlang or Elixir or any of these actor languages or frameworks, if you need to handle lots of connections. So I guess WhatsApp is the most famous currently example where Erlang was used. So where there's really lots of connections. We could compare it to, for example, this thread pool, thread-based concurrency model. So that works mostly fine. But when you have really lots of connections, then threads can become expensive, the context switches can become expensive, and the logs can become unpredictable. So Erlang runtime doesn't have any of those really. It's just when something is running on the core, it's really running there, it's never sleeping, never blocking, and it's just performing the process itself. It's just a really simple thing. It itself doesn't consume too much memory. Distributed actors can run on the same host or whatever host. Error tolerant, there's this idea called let it crash, often associated with actor systems. So if something goes wrong in an actor, let's say invalid input, some bad input, or a Solafare has flipped a byte in the data center, we handle that as the same kind of error. We just let the actor crash, let some actors crash, restart those, reset the state, much like you would reboot your computer when it starts to misbehave. Finally, word of warning, if you're, this is speaking from experience, if you want to apply actor model in your system, don't overdo it. Don't make everything an actor. We are used to programming in such a way that we call from module A, module B. We know the public interface of the module B. We can put debugger breakpoints there. We can see from both sides who has called what. We can very clearly see the state. This, unfortunately, isn't so easy with actor models, since the receiver doesn't really care doesn't know necessarily who has called it. It can be called wherever, multiple messages coming in. So the state can be really hard to figure out at times. So just use it where it fits. Don't have you can have lots of actors, but don't have too many different types of actors. I would say that summarize how to use the actor model. That's it. Thanks. Do we have some time for questions?
Right. Go ahead with the questions.
Please.
So what's the benefit of Elixir over
I would say mostly the syntax, because Erlang has this really, it's quite unfamiliar. It's quite unlike any other language. So that's perhaps the main benefit, why I, for example, started to use Elixir instead of Erlang. Yeah, you can take a look at the Erlang syntax. I barely understand it, although I have read some code written in it.
Are the IO operations also non-blocking?
Well, they sort of are. I don't know exactly the exact details of how the Erlang runtime works at those cases. File IO operations, they are blocking in that sense, but they still, when the Erlang scheduler runs the processes, it can then give out, while it is doing the file IO, the permission to run some other process there. So there's some magic. Then when there's some kind of network IO operations, those are handled even in more non-blocking way. But I'm not so expert on the technical details, how those are done. Yeah, basically in every library, at least in the standard library, it's as non-blocking as it can be, I would say. So you're really using only the amount of threads that the operating system gives by default configuration.
Do you use do you have any general examples on where you use it at Ericsson or?
We are using actually this actor model. We are using Akka for Java development. We are using actually it as this web application, front-end kind of an application. So it's perhaps not the typical use case in which we use it, but yeah.
All right, I guess we're good. Thank you.
Thanks.
All.